chromium, iron, copper, nickel, vanadium, manganese. Ions of those elements have color. You don't need to memorize what all their colors are. They have a myriad of colors. But you should know that if you have a transition metal ion, it probably has some non-clear color. And just knowing that is helpful. If it gives you a series of ions and asks you which one might be not colorless or whatever, then you're going to choose the transition metal. There's probably only one polyatomic ion that you do need to know the color of. For manganese. For manganese. What color?
Purple.
Purple, yeah. So one that looks like grape juice.
Permanganate purple.
This year.
Permanganate purple. Per.
You got some of it on your hand? Yep. And it turns your skin brown purple color. Yep.
Wait, I have a question. How do they why do they have like special colors? Does it have to do with their like electron valency?
Yes, it is. And the fact that I don't know exactly what I can't answer why.
Alright.
It's a physics question. Ask Mr. Morrison. He'll probably.
I knew it had something to do with like valency or something.
Yeah, I think it is. Yeah, the D electrons are becoming excited by visible light or something. Well, they're not excited because that would mean they give off light. But yeah, they're interacting with the light and absorbing some wavelengths, which gives it color. Yep. Anything else about the exam other than colors of things that you wanted to ask about? So there's 46 questions on the exam. Some people finish with like a half hour left in the class. Some people finish with more than a half hour left. And then other people take the whole exam period. So please remain quiet the whole time. I mean, that's usually not a factor in our test periods in here because the test takes everybody the whole time. But the exam, some of you aren't going to take the whole time. So occupy yourself. Bring a book or an iPod or something.
A big coat to take a nap on.
Take a nap. That's fine. What?
Snuggie.
Yes.
And a pillow, yeah.
It grosses me out. But I guess if you don't.
Got him.
Photo.
We good on the exam now?
Yeah.
I saw a couple of you were in the class yesterday after school for a while. That was cool.
Going
and
hard.
You're gonna do well because of that.
Wait, who stayed after?
Some people.
Pogos? Weak. That's not funny. Did you call me weak?
Way stronger than you, Das.
No, yeah. I'm strong. Somebody arm wrestle me 1v1 right now.
Academically strong.
I'll do it on.
Wait, who? Wait, that's a lie. They're pogos.
Melissa?
All the academically strong people would mean.
The whole exam period, which is an hour and 20 minutes or so. So yeah, it's about, well, what? It's about 2 minutes per question, just under that. You'll have plenty. If you have studied, you're going to do well. You studied well.
Wait, if you aren't the question formats all the same? So if you like know how to do every problem on the review, you can like be done in like 20 minutes.
Yes, some people finish really early and they get 100%. We get a lot of 100%. We never have a curve.
Watch this be the first through the curve.
Typically, the averages are in the 80%.
Oh, that's good.
I have a question. How long can you stay after school? Like if I come in after school today.
Oh, I thought you meant how long can you continue the exam after the exam period. I was going to say to that, not much.
Wait, could we, like, 10 minutes or something, like, into...
If it takes you that long,
because it's second hour, right? Cause
yeah, but no. 5 minutes, maybe like at the bell to end class or the bus stop. Boomy, your question, how long can we stay after? As long as you want.
Okay. Can I sleep?
Just sleep here.
Go ahead.
Here, bring a pillow, just sleep here.
Okay, let's move on. I put up on the board today reactions of acids in water and bases of water. I wanted you to see this in a little bit of concise way because acid reactions can be written 2 different ways. This is the most common way that you'll see written and that I'll do it, where you have the acid, it is aqueous, so you know that there's water involved here because the medium is water. And then it breaks up, gives off a hydrogen ion, and then the A term. We decided that A is called the conjugate base. You can also write the dissociation of acid like this. This really is more correct. I don't write it like that, but it's more correct. Because what?
Because there's like 3 H's, so it's triprotic.
Kind of. Hydrogen ions do not go free in water. As soon as an acid releases a hydrogen ion, it immediately gets bonded to a water molecule. This really is the way hydrogen ions are in water. They're not free. So it's not physically accurate to write an acid, a hydrogen ion like that. This is really what it is in water. Yeah?
The top one just discounts the the H2O.
Yes. Yeah. Now, you can write it like this because when you're doing an ice table, this term is neglected because it's a liquid. It's not aqueous or gas. So what I'm telling you is these two things, even though they're physically not indicating the same thing, representationally they are. They're the same thing. So even if hydronium ion and H plus are the exact same thing.
So you don't, like the other acids, bases, you don't have to consider like the number of hydrogens to like when you're doing like the ice table or whatever. Like doesn't the number of hydrogens on the bottom change things, like your ratios?
No, it doesn't. The concentration of this is the exact same as the concentration of this. If I have 0.1 molarity of hydrogen ions, those are all attached to water molecules to make this. It would be 0.1 molarity of hydronium. It's the same thing. Okay? So I just wanted you to see that. Really, there's an interaction with water that I'm kind of not showing you. It's there. Bases in water, they'll always react with water. You can't leave the water out of this thing because what is a base doing? It's taking a hydrogen in. From what? It takes it in from water. The hydrogen has to come from something. So you can't leave it out there. So you're going to have the base, whatever it is, plus water yields the base now with a hydrogen ion on it. That would be its conjugate acid. And then the hydroxide ion. That's what's left over from the water molecule after it loses its hydrogen. Keep in mind how you identify whether something is a base. Acids are pretty easy. You can recognize formulas of acids. I'm not worried about you. But the bases, they're a little sneaky.
So it's
and
not an
amine compound is a base. Remember what amines are?
Yeah.
NH3.
NH3 is one of them. Anything else that you know of?
Something with N? NH2?
It should be an organic compound with N on it. Look for C's and N's and H's. The H's don't.
Wait. If we are only doing acids, bases, acid and base reactions, and we can recognize acids, can't we just like know bases by default?
Yeah. If you look at it and say, "Well, that doesn't look like an acid. This is base." Unless it's neutral and I'm messing with you.
What? Then how?
So
also, you know how we call this thing a conjugate base?
That's a question.
Does that mean it's basic? Yeah. So that means that one of these ions, you can have a negative ion that could act like this bead term. Would it give you something that's positively charged over here? No, it's going to be neutral. Or if you can have a -2 ion, like the carbonate ion is basic. It's got a -2 charge. So when it gains a hydrogen, it's going to be HCO3 with a -1. It has to go up by 1 from what it was originally. You okay with that?
Mm-hmm.
All right. So we're going to see more about bases today. We were really focusing on acids yesterday. And you ready for this?
Yeah.
Wait, what do you mean if it's neutral? Is there like no reaction?
Yes. Yep.
But isn't that... Oh, okay, that base can have its own original charge.
Why not write this down? We did it yesterday. Yep. Percent dissociation. You're going to... really, the percent dissociation is the exact same calculation as when you're checking the 5% rule. Percent dissociation is what percent of the original concentration of your acid or base has dissociated or is ionized. All right, Boomy, let's go to the next slide. Focusing now on bases. A strong acid, remember, has just a single direction arrow. It's a one-way street. So the hydrogen and A are made. There's no chance of the reaction going back the other way.
Yeah, there is.
No, there's not. Remember that part about being a miserable person when I was talking about yesterday? Is that you? It is.
Wait, can you...
Can I what?
If you write on the quiz that it almost like goes to completion, but it can because it has like a Ka value.
Stop it. Just stop. No. It goes to completion. So how good is this A at being a base? How good is it at taking a hydrogen in? Not at all. It's no good. It's garbage. Worse than garbage. Even garbage you can burn and get some energy out of. This is nothing.
But it's very inefficient. So it's not really
Why?
So strong acids make weak conjugate bases.
Yes. Yep. And if you have efficiency, a strong acid, which was one of the 6, then this is not basic. So what do I call? Can I call A the conjugate base of a strong acid? Can I
Yeah.
call that the conjugate base? It's not basic. Normally you're going to hear me call it the conjugate. I don't like even to use the word base because it's not basic at all. Basic means it has some ability to take a hydrogen in. They don't. However, and I'm using the same HA for both these strongs and weaks. Sorry about that.
Did you say? Okay, really not at all. That's why. Okay.
Yes.
So it can't take a hydrogen. So if you like,
It can't take a hydrogen. Even if you want it to.
wait, why? Like,
Because that's what the definition of a strong acid is. It breaks apart. We're never, ever, ever getting back together. So this anion cannot take any hydrogen. It's broken up for good.
oh, I got it.
Good morning, Jacob.
Such an apple. I didn't.
All right, yeah.
well, thanks. No.
Now, let's talk weak acids. The acid dissociates with a two-way street. It's an equilibrium, a reversible reaction. You get a little bit of hydrogen in A. This A is a fairly strong base. It is able to take a hydrogen in, so it can go back the other way. It turns out that the stronger HA is, and now we're talking weak acids, right? So weak acids can be judged whether they're stronger or weaker than others. The stronger this thing, the weaker the A. And the opposite is true as well. As this is weak, if this is a real weak acid, that's a strong base. So this goes back to this concept right here. Remember when I showed you this yesterday? Ka and Kb, when you multiply them together they give you Kw. You remember doing that yesterday? This refers to an acid, and Kb would be its conjugate base. If this number is high, then this number has to be low.
Wait, what does that mean? Stronger than H2O. Like, does that mean it's more than 7?
Okay, I want you to check this out. Yes, the answer is yes. If I asked you to compare water and the perchlorate ion, which of these is a stronger base?
Water.
It's an obvious answer.
Water.
Water. Right. Why? Why not this one?
Because that's made from
This is not a base. It cannot take a hydrogen ion because it's the conjugate of a strong acid. Yeah?
Yeah.
All right. What about this?
Savage easy, guys. Dang, Satvik, you don't have to be so cocky.
What?
Between these two, this is the conjugate base of a weak acid. This is better at taking a hydrogen than this. So that means if I have a solution that has NO2 ions in it, and of course there's water there, if I add some hydrogen ions, this is going to take the hydrogen before that will. That's what that means to be a stronger base. Did you catch that?
Yeah.
If I have both of these together, mixed together, and I throw some hydrogens on it, like from an acid, this is going to accept the hydrogens before that one. Even though this can't accept hydrogen, if there's nothing else around to accept the hydrogen, water will. But if these two are competing, then this one wins because it's a stronger base. Yeah? All right. Movie, let's move on. So, I don't want you to, I don't know if we want to give you time. Go ahead if you want to write that down.
Amphoteric.
You should know that water is considered amphoteric. Amphoteric means that water is able to get rid of a hydrogen, which means it's acidic, and it can take a hydrogen, which means it can act like a base too. There's only a few things that are amphoteric. Other than water, you can identify things that are amphoteric too.
Like what?
I'll tell you when we're done writing.
Wait, what's the pH of blood?
It's around 7.1 to 7.4.
So is that amphoteric?
Kyle? 7.1 to 7.4? Blood? Yes. You're just telling me that.
Yeah.
Threw it out.
Yeah, it is.
Oh.
Okay.
So is that amphoteric?
Huh?
Is
that
blood
amphoteric?
amphoteric?
That's a buffer system.
Huh?
Oh, yeah. We're going to talk lots about that.
Wait, what's the chemical equation for blood?
Oh, man, there are so many things in blood. You can spend your whole life identifying things